Section 7.6 is where we're going to start graphing some of these exponential functions. So an exponential function will first off have this form where we briefly touched on in the previous activity, where you find a number times some power, and then all of this other is just saying that a can't be 0, this has to be bigger than 1, and this can't be equal to 1. So notice that for your graphs, they're always going to be some kind of a curve. Okay, so this first problem is just identifying if I'm a linear or an exponential function. If I'm going to be linear, that means that I'm going to have this kind of form where it's y equals mx plus b. And if I'm going to be exponential, then that means I would have this kind of form where it's y equals a times b to the x. The other thing that's different about them is that if it's linear, my graph is going to look like a straight line. For a graph that's exponential, it's going to be more of a curve like we discussed earlier. The other piece that's important is if they give you a table of values, linear means I'm going to be adding the same number every time. Exponential means I'm going to be multiplying by the same number every time. So there's some distinct differences between the two. So let's take a look here. Letter A asks me, does this table represent linear or exponential? And then explain. Well, I'm going to look at the outputs, which are the y's. The x's don't really matter in this case. So I look for a pattern going from one y to the next y. So the first thing I would do is check, can I add something? So I could add -1 plus -2 and I would get -3. If I add -2 to -3, I would get -5, which is not the case. So I know that I'm not adding. I do also notice that I could multiply. So I could take -1 times 3, and then I could take -3 times 3, and then -9 times 3. So notice that it stays consistent in that pattern. So since I'm multiplying every time, this is an example where I am exponential. And the reason you are exponential is because the y's are being multiplied by 3 every single time. Now on the next piece, I have just y equals 3x. This is in the form of either this equation or this equation. Well, there are no powers where it says like 2 to the third. There's no powers in here. So automatically, this has to be linear because my equation does not have a power. It is more of the form of y equals mx plus b. Okay, you're going to pause the video and try the got it question. So in the got it question, my first one is a table. So I have my x's going up by 1, but again we don't look at the x's. My y's, I find out that I'm just adding 2 every time. So in this case, since I'm adding 2 every time, I am linear, and I'm linear because I am not multiplying, I am adding every single time. On the next one, I have an equation. Notice that we have a power where we have 6 to the x power. So that means I'm going to be exponential, and it's exponential because it's going to be in this form where you have y equals a times b to the x. Alright, last piece, looking at some word problems. First word problem. It says, suppose 30 flower beetles are left undisturbed in a warehouse bin. The beetle population doubles each week. So we can give this function. We start with 30, and then I'm going to double. So I have my initial amount and then my growth rate. This is given in the population after x weeks. So x is in terms of weeks. How many beetles will there be after 56 days? So important information. Here's my function. I have 56 days, but keep in mind that x is in terms of weeks. So before I can just plug 56 in there, I need to turn this into weeks. So think about how many days are in a week. So there's 7 days in a week. So I would take 56 days and divide it by 7, and I would get 8 weeks. This is the number that I would want to plug in for the x value. So I would write out my equation, and in replace of x, I would put 8. Then I would do order of operations. So 2 to the 8th times 30. And I would get 7,680 beetles. Make sure you have a label since now we're talking about word problems. Alright, pause the video and try the got it question. So in the got it question, here was your function. You're trying to find after 3 years, and x is in terms of half years. So if I have 3 years, thinking about in terms of half years, so 1 year would have 2 half years. So thinking about just multiplying 3 years by 2, that means I would have 6 half years. So I'm not going to plug 3 in for the x spot. I'm going to end up plugging 6 because they're cutting each year into 2 halves. So then I plug in 6 where the x goes. So I would then type in 3 to the 6th times 20, and I would get 14,580 rabbits. Again, make sure you have a label because it's a word problem. All right, you're going to then start working on the worksheet.